Hello everyone, I'm Jay Vilatkar and welcome back to my YouTube channel. So today we are going to discuss about Deep Research Assistant. So imagine asking any question about market trends, academic topics, technical deep dive and getting a clean structured professional report without sending a single token to OpenAI, Anthropic or Google, and no monthly subscription, no data queries, completely offline after initial setup. So that's exactly what I have built. A deep research assistant running 100% locally on my MacBook using brand new Jan V1 4B model. So in this video, I will walk you through what it does, how it works under the hood, and why I chose Jan V1 and show a live demo. If you are into local LLMs, agentic AI, RAG, or just want privacy first search tools, stick around please. So why did I build this? I built this because most AI research tools rely on cloud APIs, which are very expensive to scale, and your data goes to someone else's servers, and you are limited by rate limits and token costs. I wanted something that runs entirely on my local laptop and can do real web search, which is via Serp API key. So it produces high quality structured reports in different styles like executive, academic, detailed, etc. and also uses a strong reasoning model to punish ways above its size. So it runs, so I enter a model called Jan V1, which is a 4 billion parameter model, which is released recently, that is specifically tuned for agentic reasoning, tool use, and multi-step problem solving. So this quick facts about Jan V1 are that it runs comfortably on most modern laptops with 8 to 16 GB RAM. It is built on Qwen 3.4b thinking and has a Lucy architecture, which is excellent for chain of thought and tool coordination, and achieves 91% on simple question answers. That is much better than some 70B models on factual QA, and uses a GGUF quantized model. That means it uses a quantized form version and has a context length of 4096 tokens, which is enough for serious research synthesis and is designed explicitly for agent workflows. So it's perfect for research automation. When I compare it to generic 7 or 8 billion parameter models, I notice it is sharper on multi-step reasoning and it stays on task, exactly what we need for research agents. So let's take a look at the tool demo. So basically in this tool demo, I have typed a research topic, that is impact of AI in IT. I have selected a research depth, that is moderate. I have selected time frame, that is recent, and have selected a focus area, that is general focus area, and also last is format report, that is it is a detailed analysis, and clicked on start depth research. After clicking on the depth research, I get this results that with this heading, that is research report impact of AI in IT, and this final synthesized report, which it gives a detailed analysis of it with its sources present over here, which has been extracted from the web. You can see the sources as well. So these are the sources. You can download it as text, JSON, etc. So let's go into the technicalities of it. So over here, this is the code for the Deep Research Assistant, where I have imported various modules like Streamlit, llama CPP, etc. So these two are the important modules used over here. So first function is the format function, where we have to choose between various types of research, that is executive, detailed, academic, or presentation, that what type of research do we have to do. Then there comes another function called extract final block, where it extracts relevant sections of a topic for that relevant research, so that it could understand the LLM that how the research is being carried out and what type of summary or what type of research pattern it requires. So for that, it extracts various relevant blocks from it and then sorts it in in descending order. After sorting it in descending order, it is then matched and then returned as cleaned text. After that, I have created a class called research config where all the configurations are being set. That is model path, max token, temperature, float, top P, top K, context length, search API key, search engine. So these are the search configs. So for model path, you have to download the model Jan V1 on your laptop. So it's not that difficult for you. So I will tell you how to do it. So basically, you have to run a command for that, which I will tell you in the later stage of the video, and then let's discuss the whole code first, and I will tell you how to download it later. So after that, I have a class called deep research assistant where I configure these configurations in a variable called config. So basically, config is also a research config type variable used from this class, and then I define LLM as none and demo mode as false. After that, I create a model to load it. So for loading, we first check if the path exists. If path is not there, the file is not loaded. If path exists, the model file is loaded, and then it is used as a configuration in the llama module, as I have used llama module for its good reasoning capabilities, and and deep research capabilities as well. So basically, I've used the model path and context length over here. So after defining it, I have tested it. If it prints hello world and the boolean is true, then it says model is loaded. Model is loaded. If it is not, then it says the test generation failed. So in my case, the model was loaded. As you can see from here, I will show you the path. So over here, you can see the model has been loaded, and it says model loaded. You can see it over here like this. So let's go to another function, that is generate response. Over here, the response is being generated. For that, the response has to be cleaned based on the model response. So we first clean the response based on the stops, like these stops or any other extra stops. For that, we store it in the stops and then check if it is inside the max tokens or not. If it is not, it is then cleaned and then given to the LLM, and then the LLM produces a response, and then it is again cleaned. The response is again cleaned using strip and then returned. After that, we then come to a function called search web, where we use the Serp API key. For that, we have also defined another function called search Serper, where we first extract relevant information using the Serp API key and store it in a list in the form of dictionary, where we keep the title, URL, snippet, and source. And source would be always web, as it uses the web search to search it. After using the web search, it returns the results. After which, we use another function called generate queries, where queries are generated based on the count present in it. So count means these are the points, like surface has 5 counts, moderate has 8 counts, depth has 15 counts, and comprehensive has 25 counts. So based on these research types, it chooses the depth of how much depth should I research. So based on that, it chooses various topics for the depth, that is overview, recent development, academic studies, case studies, policy and regulation, technical approach, market analysis, and statistics and data, and returns the total number of queries for that. After returning the total number of queries, we use synthesize research, where it focuses on the search results it has got, and for that it chooses the title, snippet, context lines, and then puts it inside the synthesis prompt along with the relevant text, section text, and context. After that, the prompt is then cleaned. The response is then generated using the generate response query, and then the answer is then cleaned and then returned. After returning it, we then see this answer as in the Streamlit UI present over here. You can see the answer. So this is the whole Streamlit UI where I have kept Deep Research Assistant as Streamlit session variable, and there are two columns contains research depth and focus area, and another column containing time frame and report format. So when we click on the button start deep research, it starts the research. If model is not loaded, it says model loaded failed. Otherwise, please enter a research topic to proceed if research topic is not present, else it starts the research. So it uses start research function where we first generate the queries, then we run it in an event loop. After running it in an event loop, we search the web until the loop is running completely and any queries search results have been found, and we have kept by default it as number of results as 5 for our convenience. After getting the results, we store it in a list. After storing it in a list, we then show the status bar with progress as initially 15, then 40, then 80, and then 100, like this, and get a text like synthesizing reports. So while synthesizing reports, we use synthesize research to synthesize all the research and format it accordingly. After formatting it, we then show the search results based on topic, report, sources, queries, and configurations as well. And then it is then shown in the Streamlit UI as shown it before. Otherwise, it shows an exception. So this is the Streamlit UI structure for displaying the results with various columns like research reports, and with first column containing the research report, second column containing downloading full data as JSON, and third column containing a start new research. So these are the three buttons which you can use it for downloading the data and also starting a new result as shown below. Like these are the sources where from the web which the Serper API key has shown and has extracted it, and you can see it over here. These are the search results. You can download it as text, as JSON, or start a new research again if you want. So thank you guys, thank you for supporting me, and please give a like in it. And so I will give you all the content in the description box so that you all can try. Thank you for your support.